Ignition sequence start.
Good morning. You're looking at Mission Control Houston at NASA's Johnson Space Center and the International Space Station Flight Control Team members who are monitoring the operation of systems on orbit while assisting the Expedition 63 crew members through the last few hours of their work week in space. Commander Chris Cassidy and flight engineers Anatoly Ivanishin and Ivan Wagner wrapped up operations with an American cargo ship this week, and they've started getting ready to receive a Japanese cargo vehicle that's due to launch next week.
Welcome to Space to Ground. I'm Catherine Clayton. This week, a cargo vehicle departs and begins its second mission, while another cargo vehicle prepares for launch. The Northrop Grumman Cygnus CRS-13 departed the International Space Station on Monday, successfully completing its 3-month cargo mission. The CRS-13, named the SS Robert H. Lawrence in honor of the first African American to be selected as an astronaut, delivered over 7,500 pounds of science experiments and supplies to station. With its departure on Monday, it not only carried away thousands of pounds of trash, but also began a secondary mission, hosting the Spacecraft Fire Safety Experiment 4, or SAFFIRE 4. The SAFFIRE 4 experiment will investigate large-scale flame growth and material combustibility limits in the safe microgravity environment provided by the recently departed Cygnus vehicle. It is critical for future human spacecrafts to understand how fire behaves in microgravity and how different materials propagate flames in space. The investigation will also help inform operational protocols for fire emergencies, especially in situations where the astronauts do not have the ability to exit the spacecraft. The always busy International Space Station is preparing for JAXA's H-2 Transfer Vehicle 9 launch on May 20th. This will be the 9th delivery for HTV, also known as the Kounotori. The vehicle will carry over 6 tons of cargo to the ISS. Investigations and provisions for the crew will travel in the HTV-9's pressurized logistics carrier, and ISS lithium-ion battery replacement units will travel in the unpressurized logistics carrier. HTV-9 will launch from JAXA's Tanegashima Space Center. The launch will be covered on NASA TV beginning at 1 p.m. Eastern on May 20th. The entire NASA team is excited about the upcoming SpaceX Demo 2 flight test on May 27th. NASA astronauts Bob Behnken and Doug Hurley will launch from the Kennedy Space Center to test the vehicle's crew transportation system and operational capabilities in orbit. NASA TV will air the crew arrival news conference from Kennedy on Wednesday, May 20th at noon Eastern, and the DM2 flight readiness review briefing at KSC on Thursday, May 21st at 6 p.m. Eastern. Stay tuned to be a part of the excitement. Keep sending in your questions using the hashtag AskNASA, and we'll see you next week.
As Catherine reminded us all, NASA and SpaceX have a big launch coming up in less than 2 weeks. Astronauts Doug Hurley and Bob Behnken are targeted to make history when they launch to the International Space Station from a Florida launch pad on the shiny new SpaceX Crew Dragon spacecraft.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
Certainly when you go through the launch day preparations, there's a lot of moments that kind of stand out to you.
When the engine's light, you know you are going, and you know you're going somewhere pretty fast. When the engine shut off, you go from 3 Gs to 0 Gs instantaneously, and things start floating. And I remember distinctly just thinking, what just happened?
Same thing happens when you get to space station. It's kind of a defining moment when you get the hatches back open. By sharing this experience with SpaceX and creating another partner that has this same capability, I think we really set the future up to continue to blossom.
This will be the first time humans have ridden on the Falcon 9, even though it's flown many, many times. And so just taking in that experience and the sounds and all those things that we can relate to future crews is going to be something important to do too.
When the Crew Dragon reaches the International Space Station, Doug Hurley and Bob Benken will become members of the Expedition 63 crew and join their crewmates in supporting station maintenance as well as scientific research. On this season of the NASA Explorers series, we're focusing on the scientists. And today you meet a team of researchers as they get set to launch an experiment into space for the first time in their careers.
These two tanks are from the Sphere's slosh experiment, which we've been working on up here.
Microgravity has a lot to teach us. Take these containers. The green liquid inside is showing us how fuel swirls around in a tank while it moves through space. What we learn could help us design safer, more efficient spacecraft. At any given time, we are conducting close to 300 different experiments aboard the International Space Station. Research like this is preparing us for the future of space exploration.
That's cool.
We really can't mimic the environment on the space station anywhere on this planet. And it's what makes it such a special place and why scientists from many universities, several companies, like to send their science up, because once you remove gravity, many things act differently.
This season, we're exploring why we send science to space and what it takes to get it there. Spoiler alert, you don't have to be a rocket scientist to conduct research in microgravity.
So this is our first project that's going up to the station, and our first project working with anyone involved in the space program. So it's a very exciting time for us. The transition from what am I going to do with my life in the middle of graduate school to here I am sitting in Houston getting ready for our launch. I can't hardly believe that it's actually happening.
Meet Elaine, one of the co-founders of Tympanogen, a medical device startup based in Virginia. Her company is developing a gel patch that can serve as a replacement for eardrum repair surgery. That could have huge benefits here on Earth, but launch that gel to space, and the opportunities for use grow even more. First, we have to back up a few steps. Putting your life's work on top of a rocket may seem like a daunting task, but there's a system in place to help scientists who know nothing about spaceflight get their research into orbit. You see, NASA and its international partners aren't the only source of science aboard the space station. The ISS U.S. National Laboratory creates pathways to space for companies, universities, and even young students. If you're starting a journey into the unknown, it helps to have an expert at your side to navigate the way. The National Lab connects researchers with implementation partners who provide resources and guidance for taking an experiment from Earth to microgravity. Elaine and her team are working with nanoracks.
They have the plate reader on the space station that's going to be used for our project, and they're coordinating the launch and getting all the materials together for us. We're glad that we're working with them because we're glad that somebody has done this before and can help us along with the process.
7,643.
The project that we're sending to the space station is looking at how hydrogels behave in microgravity conditions, and we're specifically looking at how the structure changes and how drug release profiles change in the absence of gravity.
My name is Paris Du. I'm a co-founder and co-inventor of this technology, and I've been with Tympanogen since day zero. Hydrogels are a very important materials. They are high volume water that can very well mimic the extracellular matrix of our body. So we really thought that answering this question can really help the scientific community.
Confused? Don't worry, we've got you covered. Think of hydrogels like a scoop of gelatin. Not quite a liquid, not quite a solid, definitely made up of mostly water. We can use hydrogels to cover wounds and even deliver antibiotics to promote healing. For that reason, hydrogels are being studied for use for things like wound care for soldiers on battlefields.
If you are far away from a hospital or a clinic and you can't get good medical care right away, and that soldier has a wound, could you apply that hydrogel directly to the wound site and begin to treat any infection that might be coming on? What about in space, though? What if we are far away from Earth's surface, on our way towards Mars, and we also have another wound on an arm or a leg, and we need a better way to treat that wound and make sure it doesn't become infected? So tympanogen, the hydrogel itself, is a great example of a dual-purpose technology. It's something we can use not only on the Earth, but up in space.
This research could provide previously unknown foundations for future hydrogel studies. It's a great example of how microgravity can offer new insights into systems we've already explored on Earth.
The data that we're collecting is so basic science that it's hard to find those sorts of projects at this stage. As a researcher, that's really exciting for us as well. And it's in space.
And when it gets to space, it goes into the hands of astronauts who will run the experiment in orbit. Just like training for launch, landing, and spacewalks, crew members participate in hours of scientific training to prepare them for running many of the hundreds of experiments that are ongoing aboard the space station. Ready to go to class with an astronaut? We'll take you along.
Well, a lot had changed in 11 years since he was up there. It was a new experiment, so he hadn't seen that either. They tell us, hey, this is a lot easier if you just go upside down. You're going to be in microgravity and this will work differently.
Scientists are using the International Space Station to develop robots to do simple tasks so that the astronauts have more time available to do things that only astronauts can do. Station Commander Chris Cassidy gives us a sneak peek at his work with 3 flying robots being developed by NASA's Ames Research Center.
The unique thing about this particular one on the right docking station, it goes in upside down. Went and got some snacks, some nuts and some hot chocolate. So the scientific team is in California, the payload control center is in Huntsville, and of course I'm here. So we've got 3 different locations, we're all working together.
The International Space Station hosts experiments in a range of scientific disciplines. Like what? Well, like research into using 3D printing technology to manufacture biological materials in microgravity, which could allow cell growth in 3 dimensions.
Cutting-edge biomanufacturing aboard the International Space Station. Presented by Science at NASA. Most likely, you're aware of 3D printing, which allows you to design and produce one-of-a-kind pieces for a variety of purposes. But what if you could use that same technology to manufacture biological materials, like new tissue or blood vessels? Welcome to the world of 3D biomanufacturing, a cutting-edge practice on Earth that is being tested aboard the International Space Station, or ISS. Dr. Mike Roberts, Deputy Chief Scientist at the ISS U.S. National Laboratory, explains why the space station is critical to biomanufacturing's future. We've been able to grow cells in a lab for well over a century, but gravity limits that growth to 2 dimensions. Cells can grow outward, but not up and down like they do in the human body. Also, lab cells are often in contact with the glass or plastic that contains them. But aboard the space station, our experiments will be conducted in microgravity. That allows you to build your cell models in 3 dimensions, without being confined to the bottom of a dish, or unable to grow in contact with lots of other cells. Biomanufacturing imagines the ability to someday grow a viable human organ. Organs are composed of specific tissue intersected by blood vessels. Most organs and thicker tissues in the body have a rich, complex network of blood vessels that provide nutrients and remove wastes from the living cells that make up the tissue. We currently lack the ability and the tools to engineer these highly branched, living networks of vessels inside layers of tissues on Earth. Another medical advantage to manufacturing biological parts in space is the potential to bypass the body's immune system. Today, organ transplants from donors are prone to rejection because the patient's body perceives the new organ as a foreign object, and their immune system tries to attack it. But with the ability to grow tissue in space, a person could conceivably have their own cells used to make their new organ, which might avoid the body's rejection. 3 different types of biomanufacturing facilities will be tested aboard the space station. 2 of them perform in a manner similar to a standard 3D printer. They extrude cells in layers to build tissue. The 3rd type uses powerful magnets to position the cells in place. Each of these 3 different approaches to bioprinting in microgravity will be available to medical researchers seeking to better understand how to engineer tissues and organs for use in repairing injury and curing disease on Earth. As Dr. Roberts notes, the 3D bioprinters represent cutting-edge technologies that could clearly benefit health outcomes on Earth. I think the ability to manufacture a fully functioning human organ will take some time, maybe a decade or more, but the knowledge we'll acquire to get there will also create interim benefits as we learn more about cell regeneration in space and its application to humans on Earth. For more inside information about studies inside the station, visit www.nasa.gov/ISS-science. For more on science happening on, around, and beyond our planet, go to science.nasa.gov.
NASA's Artemis program will expand on the achievements of the International Space Station and open the door for humanity to live and work sustainably on another world for the first time, first on the Moon and then on the planet Mars. Actress Kelly Marie Tran tells the story of how we're going to put the first woman and the next man on the Moon by 2024.
Between 1968 and 1972, America launched 9 human missions to the Moon, 6 of which successfully touched down, allowing 12 men to walk on the lunar surface. NASA's next chapter of lunar exploration, called Artemis, has the task of not just going to the Moon to create a long-term human presence on and around it, but also to prepare for ever more complex human missions to Mars. In short, everything we must be able to do here, we must first do here. So, what will an Artemis mission look like? Everything is designed and tested with our most important element in mind, the astronauts. This is their deep space, human-rated spacecraft called Orion, built in 3 parts. The crew module, where up to 4 astronauts will live and work throughout the flight. The service module, with life support systems for the crew and its own engine and fuel reserves. And a launch abort system, with engines capable of pulling the crew module to safety during launch should anything go wrong. To accomplish the task of launching our crew and heavy payloads, NASA is building the Space Launch System, comprising of a cargo hold, an exploration upper stage, a massive core stage, and 2 extended solid rocket boosters. Altogether, this is the world's most powerful rocket, and it exceeds the legendary Saturn V of the Apollo era in numerous ways. Sitting on the launch pad, the entire rocket, fully fueled, weighs just over 6 million pounds, 5.2 million of which is just the fuel. Once ignited, there is no stopping what comes next. All 4 RS-25 engines and the 2 solid rocket boosters come to life, thundering our crew upwards. 2 minutes after ignition, the solid rocket boosters are spent and released. 8 minutes after launch, the core stage is depleted and separated. The upper stage fires briefly, placing Orion into a parking orbit around the Earth. Here, the crew reconfigure the spacecraft and check systems to confirm everything is ready for deep space travel. With a go from mission control, the crew reignite the exploration upper stage engines to leave Earth entirely. The exact timing of this maneuver is critical to reach a speed that can escape Earth's gravitational pull, but also put Orion on a course that will intersect the moon days later. Once this burn is complete, the upper stage of the SLS is jettisoned and the crew aboard Orion coast for several days toward all that awaits them at the moon. Approaching the moon, we see the fundamental differences between Artemis and Apollo. Instead of requiring Orion to serve as an expendable lunar command module or to carry a constrained lunar lander, the Artemis missions will take advantage of a different approach: pre-staging. Everything needed for lunar missions will be positioned in advance by commercial and international partners. This includes rovers, science experiments, and human-rated systems on the surface. But it also includes a dedicated lunar station in orbit around the moon called Gateway. Here at this station, we can pre-stage a robust lunar lander and establish a strong communications relay. Designed with open standards, the Gateway can be expanded as new missions and partnerships develop, allowing multiple human missions on the moon at the same time and enabling ongoing science to be conducted even between human missions. The Gateway is also capable of adjusting its orbit to allow access to every part of the moon, something the Apollo missions could not do. But the real key in this approach is placing Gateway in a unique halo orbit to perfect the maneuvers needed for Mars missions. And with the growing list of commercial and international opportunities, Gateway is the ideal hub between Earth and all that lies beyond. Returning to our crew as they approach Gateway, the Orion must match the elliptical orbit of the station in order to successfully dock. Once on board, pre-selected crew members transfer to the lunar lander, while those assigned to Gateway remain on station. The lunar lander system itself is built for 3 unique steps: descending from the halo orbit of Gateway down to a low lunar orbit, descending from low lunar orbit to the surface, and once the lunar mission is complete, launching from the surface of the moon and ascending all the way back to the orbiting Gateway. Once back aboard the Orion spacecraft and undocked from Gateway, the crew fire their engine once to break out of the halo orbit and once again to sling the spacecraft around the moon, placing it on a multi-day trajectory back towards Earth. As they near the end of this journey, the service module is released, and the crew module is oriented heat shield first. Entering Earth's atmosphere at 25,000 miles per hour, the friction of air slows Orion considerably, while also subjecting it to temperatures of 5,000 degrees. With the Orion now at just 300 miles per hour, a series of parachutes uniquely tested and produced for this moment deploy, decelerating the craft to just 20 miles per hour for splashdown. With each successful mission, Artemis ushers in the next wave of men and women to explore our moon and prove that together we are ready to go beyond.
According to reports from the select few who've had the chance to see it, the experience of seeing Earth from 250 miles up is a profound one. Some of the lucky astronauts who've been to the International Space Station multiple times say they see more and more details of the planet and of space beyond with each opportunity. Astronaut Don Pettit, a 3-time visitor, is a good example.
I thought I knew what the Earth was all about just because I'd looked at it with pictures and video and all these things. And it's like seeing some travel log in some exotic place on Earth and calling that your vacation, right? We do not do that as human beings. We want to physically go to these places because the experience is different. And it's the same thing when you go into space and you look at Earth. You know intellectually what Earth is like from space because we've all seen the pictures, but it's not being there. The human experience aspect of space doesn't come until you can relax a little bit. Now, that happened for me when I was taking my spacesuit off, and I remember floating up to the flight deck, and you look at the overhead windows, and Earth was there, and it was such an intense blue. It was somewhere over the oceans, and it was an intensity of color that no photography, no video, no movie, no film can capture. You can parse more and more details out. When you first look at Earth, you may say, wow, that's a continent. And then you look at it again the next day and you say, wow, there are mountain ranges. And then you look at it again the next day and it's like, oh, I can see synclines and anticlines in the geologic structure. And oh, there's the rain shadow effect, and on and on and on. So the more time you have to look at Earth over a long period of time, the more you can see. So there's more to see in space than just looking at Earth. You look out at the cosmos, and there's many things in the cosmos that are noteworthy to gaze at. And for example, the Magellanic Clouds. Those show up really bright and vivid because you don't have atmospheric scattering. You can see Andromeda. It's a little fuzzy spot on a really, really dark night with good vision. You can faintly make out Andromeda, but in space it just stands out because the contrast is so stark. So there's all kinds of other things to see. There's the moon. It goes through its phases. The angle that the moon makes when it rises relative to your spacecraft changes with time. It's almost like your spacecraft itself becomes a giant astronomical machine, and it's like, okay, the moon was rising over here 2 weeks ago, and now it's rising over there, and why is that? And then you think about the orbital dynamics, where we are in our solar system, this and that, and then it all makes sense. So there's so much to observe, more so than just planet Earth. Yeah, I think it's important to share our experiences with all the people who, as of today, don't have a chance to go into space. But the more people that we can get off of this planet to have these kind of experiences, the more growth you will see in ideas, and the viability of your culture will increase.
If you'd like another look at the stories we feature today, check us out on YouTube and Facebook. There are the addresses. Be sure to look around because there's a ton of cool stuff to see there. While you're out on the internet anyway, you could also check out Houston, We Have a Podcast. It's conversations with folks about their work in many aspects of space exploration. New episodes post every Friday. Today, Gary Jordan talks with two of the crew systems instructors who teach NASA astronauts how to use the personal hygiene systems on the International Space Station. Yes, they will answer that question. Go to nasa.gov/podcasts for this week's episode. It's where you'll also find all the previous episodes and the full library of all the NASA podcasts, all of which you can also listen to on Apple Podcasts, Google Podcasts, and SoundCloud.